And now it is my pleasure to introduce our speaker tonight, Kim Adelson of Black Hills Audubon, as our presenter. I hope many of you heard her first presentation to WOS on the dinosaurs amongst us, and or her second presentation on the birds that lived with the other dinosaurs. If so, you already know of her passionate interest and expertise in paleontology. If you missed these presentations, they're available at the WOS YouTube channel. Tonight, Kim is leaving the Cretaceous period far behind. She's going to try to answer the following questions. When did familiar, recognizably modern birds appear, and which came first, the chicken or the songbird, or the penguin or the raptor? Answering these questions is challenging for reasons that Kim will explain. I'm happy to turn the mic over to her now for a stimulating presentation that will bring us up to date on the current status of this unfolding story. Thank you, Kim.
Thank you, Vicki, for that really nice, this will stop other people sharing, go to my screen, share. Okay, that should work. Anyway, thank you, Vicki. That was really nice. Unfortunately, I'm not totally leaving the Cretaceous behind today. We have to keep talking about the Cretaceous too, but as Vicki told you, this is my third talk for WOS. The first was had to do with the proof that birds are in fact living dinosaurs, not just that they evolved from them. The second one had to do with the characteristics of birds that were alive during the time of dinosaurs. And this one, as she said, is about the origins of modern birds. And I'm going to see if I can shrink this down because I'm finding it very irritating. Here we go. Now I don't look at myself. A few things I want to say before I get going. The first is that this is a very difficult topic to talk about. And the reason for that is that the data are messy. There's a lot of contention about various aspects of what I'm going to say. And I'm going to do my best to tell you which things almost everybody is in accord on and which things there's more disagreement about, which specific issues there's more disagreement about. But this is a rapidly evolving field. Virtually every month, something new comes out that tweaks what we know or we think we know. We certainly don't have the whole picture. This is going to continue to evolve, but I can give you a snapshot of what we believe right now about the origins of modern birds. The second thing I wanted to say, it's a little bit of an apologia. I'm just going to say dinosaurs and birds. I find it cumbersome to say non-avian dinosaurs all the time. Or, you know, so if I say dinosaurs, you know that I mean classic dinosaurs, and I'm in no way trying to imply that birds are not dinosaurs. But with that, I think we could get going, assuming my computer's going to work. There it is. All right. Well, I'm going to start off with a little bit of a review to ground us. Here's the Mesozoic, the age of dinosaurs. What I wanted to tell you is that the latter half of the age of dinosaurs was a world where the skies were filled. Not only were there tons of birds, the first birds evolved about 140, 150 million years ago, right at the very end of the Jurassic, and then existed throughout the rest of the age of dinosaurs. There were lots and lots and lots of birds. And there were not only lots of birds flying around or walking on the ground, there were also flying dinosaurs, classic dinosaurs. There were also animals that are halfway between birds and dinosaurs. And then there were flying reptiles like pterodactyls that weren't dinosaurs, but were still flying in the air. So the air was a very crowded place. And again, there's no doubt, everyone agrees that the first birds evolved roughly somewhere 140, 150 million years ago. At the very end of the age of dinosaurs, there were lots of different types of birds, but you can divide most of them into three general types, three different orders of birds. And I wanted just to review that. So the most common kind of birds you would have seen back then, we're talking 70 million years ago, 80 million years ago, pretty much right before the end of the age of dinosaurs, were the enantiorniths. And the enantiorniths are diverse, they're numerous, they were found on every continent except Antarctica, and maybe there we just haven't found a fossil yet. They filled all the passerine niches, woodpecker niches, some of the wader niches. So they were, very, very successful, very, very broad and widespread. They differed from modern birds, and they were an evolutionary dead end. They did not evolve into modern birds. They had claws on their wings. They had these funky tails that had two really, really long feathers. It's hard to see here, but they had teeth inside their beaks. And the reason we know they're not related or even closely related to extant birds is that their shoulder joints are just entirely different than a modern bird's shoulder joint. So that's what was there. This was the most numerous. This is the most likely kind of bird you would have seen if you go back towards the end of the Cretaceous. Another bird that was very dominant are the Hesperanists. These were birds that spent all of their time in the water. They lived in both freshwater and salt water, and they're kind of a cross between a penguin, a loon, and a cormorant when you look at them. They were flightless. This one has long wings, but some of them had very, very tiny vestigial wings. We know that they spent all of their time in the water because their legs are so ridiculously placed so far back on their bodies that even further back than a penguin's, there's no way they could have stood up. When they got onto land, like to lay their eggs, they would have had to crawl on their bellies, slide along on their bellies. So these were definitely water birds that were totally helpless on land. They're only found in the Northern Hemisphere. Again, quite widespread throughout the Northern Hemisphere. And again, they had teeth. All the birds, these three types of birds, each of them had teeth. And then the third and final type of archaic bird that was around right at the end of the Age of Dinosaurs that I wanted to mention are these, the Ichthypus. They basically look like toothed gulls. And I love this artist's representation because there they are attacking and mobbing a pterodactyl, which, just really drums home that they were there during the Age of Dinosaurs. These also were birds that were confined to the Northern Hemisphere. I'm mentioning hemispheres because Vicki asked me about the birds evolve in the northern southern hemisphere. So now I'm thinking about what hemisphere all the birds are in. Okay, so that's what the sky was like. These were the most common birds you would have seen 67, 68 million years ago. What happened is I'm sure most of you know, is that 66 million years ago, an enormous asteroid crashed into Earth. Where it landed is what is now the Gulf of Mexico. And it was so big and it was going so fast that it just caused utter devastation. Certainly anything within 1,000 miles, most of the United States, most of Brazil, everything was completely decimated in a matter of seconds, if not minutes, in that region, though the effects were global. I'll show you that in a minute. 75% of all the land animals on Earth died when that asteroid struck, or shortly after that asteroid struck. That includes all the non-avian dinosaurs and almost all of the birds, okay? Sometimes people don't want to believe that birds evolved from dinosaurs because they say, well, the dinosaurs died out and the birds were fine. That's not true. Virtually all the birds died out too. I can tell you that essentially 100% of all the animals, no matter what type they were, that lived in forests died out, and almost all the animals that were larger than about a rabbit died out. And so, there were a few straggler birds, there were a few straggler mammals. Mostly for mammals, it was mostly mammals that burrowed underground and ate insects or seeds that were buried. That's how they managed to survive. But in any case, the Enantiomorphs died out, the Hesperanists died out, the Ichthypus died out, and the world was a very, very different place. Now, this slide is really out of date from Kring in 2000, but I think it just gives a very nice quick overview of how profound the effects were. And I can tell you that nowadays, if you were to redo this, you'd make them worse. The idea is that the asteroid was worse than had been previously thought. But really what I'm trying to point out is though there were some effects that were local meaning, again, most of the United States to most of Brazil, including an earthquake. This one really gets to me because I lived through a major earthquake, actually several, when I lived in New Zealand. And we shook for 45 seconds, which was considered unbelievable. They now think that the earthquake was bad enough that the shaking went on for months. And let me tell you, that would kill you if nothing else did, because even if nothing fell on you, when the earth is bucking the way it does in a major earthquake, all you can do is lie there. I mean, you can't even stand up, you fall down again. So you can't search for food, you can't lay eggs, you know, you can't brood your young. I mean, so locally things were just horrible. But the point is that globally, there were all these other effects. There were toxins falling from the sky, there was acid rain, there was a nuclear winter that lasted a long time, probably heavy metal poisoning, and then ultimately when the dust settled, greenhouse gas warming. And these effects lasted for decades. I can tell you that 100% of the forests on the planet burned down, and it took more than 1,000 years for them to recover. So again, that's why there were no forest birds or any other type of animals left. So anyway, there's this huge cataclysm that occurs, and there are very few birds left. Now, not to beat a dead horse, but when we're talking about the age of dinosaurs, it's called the Mesozoic. The last part of that's called the Cretaceous. It was 66 million years ago that the asteroid struck. So any bird that was around more than 66 million years ago lived during the age of dinosaurs. Any bird that evolved more recently than 66 million years did not. Okay, so 66 million years is kind of the key date that we really care about. And to get ahead of myself, I mean, I have a master's degree in evolutionary biology and then I have a PhD in psych, but my time as an evolutionary biologist, certainly, if it taught me nothing, it's that when you've got a lot of empty niches, which is what you did after all these animals died out, it really would be expected that there would just be an explosion of diversification, that a few species probably managed to survive, and then they just rapidly radiated outward and diversified and became all sorts of species. There's all this empty habitat, that there's no competition for. And so that's really the story we're gonna talk about. Okay, but before I can get going, this is really important. I wanted to tell you how we know when a species first appeared, because what we know is only as good as the evidence that we have. And the shorthand that's generally used for this is rocks and clocks. We know by rocks and we know by clocks. So let's talk about the rocks first. Okay, when we talk about rocks, we're talking about fossils, the fossil record. This is a very famous fossil. This is Archaeopteryx. And it was long considered to be the first bird. Now we know that it's not, and it's not closely related to modern birds, but it doesn't matter. The point is, when this fossil was found, look at this beautiful fossil. It's essentially all there, and you can even see its feathers. When you find a fossil like this, and then you can date the rocks that the fossil is in, because you don't directly date the fossil, you date the rocks that the fossil is in. And in this case, this rock is 150 million years old. You can say, well, that bird must have been around 150 million years ago. It's very hard to make any other explanation about that. The most common way we're dating fossils of the kind of ages we're talking about today is called potassium ion decay or potassium argon decay, because potassium ion changes into an argon ion. If you've heard of carbon-14, and we're thinking that was the answer, carbon-14 dating only goes back about 70,000 years, so you can't use it for these kinds of fossils, so we use potassium ion decay. A nice thing about potassium ion decay is that it is very well established. Everybody takes it seriously. There's no controversy here, and it has a very small margin of error, somewhere in the range of 0.1% to 1% off. So very, very tight. If it gives you a date, that is the right date. Now, of course, the animal could always have existed even earlier. I mean, maybe there's an older fossil out there, but it's very hard to argue when you find a fossil like this that it didn't exist at this date. Now, here's the problem. Here's the problem with fossils. They generally don't look like this. Sometimes you're lucky and this is the kind of fossil you get. This is more likely the kind of fossil you get. More often you get something that looks like this, where you get a disarticulated skeleton that's missing a lot of bones. Sometimes all you find is a skull without a beak. Sometimes you find a leg bone and a few ribs. And so what you've got to do is you've got to look at a few bones and then make inferences as to what else is there. And that's where human error can crop in. And that's why fossil evidence is not perfect, because many of the things people talk about are not coming from this. they're coming from this, and they've had to fill in the blanks. So anyway, that's rock data. The clock data refers to the molecular clock. And the molecular clock, to really simplify a very complicated story, is there are sequences of DNA, there are pieces of genes that are believed to have very consistent, that's the key, very consistent neutral mutation rates, meaning that the DNA code changes, but it doesn't significantly affect the functioning of the gene. And so these changes just accumulate over time. Again, this theory rests on the fact that you can find particular sequences of DNA where the rate at which you get neutral mutations is constant. And so when you can compare the DNA in that sequence between two species, see how different it is, and extrapolate and say, well, they must have separated out from each other 75 million years ago, or 20 million years ago, or whatever you might want to do. Sometimes they use genes, sometimes they use amino acids, but it's the same general idea. Now, there's several problems with the molecular clock. One is there's no 100% agreement as to which is the best sequence of DNA to use. And if you've got two researchers using two different sequences of DNA, sometimes you get different answers. If they agree with each other, great, but they don't always agree with each other. There's also the issue of, is it true that a neutral mutation rate is always constant? Maybe in a time of great rapid environmental change, i.e. after everything else has died off, it speeds up. So, it's resting on that as an assumption. Lastly, what I would say is that the error bars, the measurement error is larger. It's not 0.1 to 1%, it's more like 5%. Now, depending upon how precise you want to be, that matters or it doesn't matter. I'll get ahead of myself again. A lot of these birds that we want to know about, when did they evolve and did they live when dinosaurs were alive, say they come out at they first appeared 63 million years ago, but the margin of error is 5 or 6 million years. Well, if I think my best guess is 63 million years ago, but that's plus or minus 5 million years, that puts it both before the age of dinosaurs and after the age of dinosaurs. And so I can't just be sure. So this is a work in progress. They're improving it all the time. Often it's very, very useful, but it is also, like fossils, an imperfect tool, unfortunately. Okay, so that's all my intro information, because we're going to keep talking about what rocks say and what clocks say. But let's get going talking about the evolution of modern birds. Well, the first birds in the modern lineage. I'm now not talking about a modern bird, a bird that you'd have no trouble recognizing today. I'm talking about the birds that led to those birds. Most models say that those birds evolved between 120 up to maybe 150 million years ago. Depends upon which model you believe. They all had some things in common. For example, they all had kind of normal bird tails that came off a pygostyle. Think about your Thanksgiving turkey. You know how birds have a little stumpy tail and then long feathers that come off of it. That's a pygostyle. So they all had kind of normal bird tails. They were all toothed, and they only had beaks at the end of their snouts, not their whole snout. They may have only had a very few teeth, but they all had some teeth and generally incomplete beaks. This is a big point. They were all the ones we know about were semi-aquatic. I say this because now I know you guys are all birders as opposed to people not interested in birds, but I think if you talk to the average person who's not a birder and you say, what's a bird like? They think of a passerine. I mean, they think of a wren, or they think of a robin, or a chickadee. I mean, they think about a small flying bird. But in fact, the ancestors of modern birds were not. They all were much more like birds that spent a lot of time in the water, a lot of time right on shore. Not that they couldn't fly, but they were designed for fish or mollusk eating, and they were not little wrens. They also still retained many primitive features such as belly ribs. Modern birds have been the benefit of a lot of changes that make them lighter and hence better able to fly, including reducing the number of ribs, but these have a primitive number of ribs. Now, all the known examples, and there's a fair number of them, of this era bird from about 120 million years ago that were the first birds in the modern lineage are from China. Okay. This one in particular, which is the oldest of them that we know, is called Ganzis. It's called Ganzis because it comes from the Gansu province in China. And here's an artist's construction of what it would look like, kind of like a tooth. You can see the teeth in here, a toothed loon or maybe a diving duck. That is what the direct ancestors of modern extant birds look like. Something like that. Okay. Oh, they also, I think you can see it here very barely, had claws on the end of their wings. Okay. So that brings us to modern birds now. And there's no way, unfortunately, that I can talk about the origins of modern birds without talking a little bit about bird taxonomy. So the first thing you need to know is you can take all living birds and you can divide them into two major groups. So birds are a class, or a clade if you're sophisticated, but they're a class, and you can divide them into the Paleognathae and the Neognathai. Those are both in classes. Most birds are neognaths. Okay, there are very few Paleognaths. We'll talk about those. Now, I'm going to tell you a story about Paleognath evolution, and then I'm going to throw a monkey wrench into it. Because literally last Tuesday, a new article came out in Nature that, if the findings turn out to be correct, turn everything that paleontologists have been saying for 50 years on its head. And I'll talk more about that study when I finish talking about Paleognaths. But I'm going to tell you the story I was going to tell you before last Tuesday, and then I'll throw in the monkey wrench that we had thrown at us on Tuesday. Okay, so let's talk about Paleognath birds. First off, here's an example of the difference in the skulls of Paleognaths, that's the left, and Neognaths on the right. So it's an ostrich on the left and a red-tailed hawk on the right. And if you look, you can see that there are lots and lots and lots of differences in their skulls. This separation is not the main difference. It's how long and how thick different bones are, and what bone attaches to what, and what shape the bones are. But I just wanted to show you that their skulls really do look quite different. By the way, of course, Paleognathai means old jaw, and Neognathai means new jaw. So we're actually talking about the roof of the mouth. That's where the name comes from. Now, more useful than that is this. I want you to look. There are lots and lots of differences. This is a turkey skull. There are lots and lots of differences between old jaws and new jaws, but the one we really care about right now is this one here, the pterygoid bone. And from the top, if you look down, that's where it is. Okay? This bone right here is the pterygoid bone. I'm going to come back to it. Here's what it looks like from the side. It's this little bone right here under the anvil, not the anvil, but the bone under the anvil. The reason that's such an important bone in terms of differentiating Paleognaths and Neognaths is because this bone has altered in the new-jawed birds so that they can flex their top jaw as well as open their bottom jaw. Humans can't do that. When you chew on something, your bottom jaw moves and your top jaw doesn't flex at all. It's fixed, it's rigid. But in birds, like in snakes, for example, they can also bend their top jaw up a little bit. Actually, neognate birds, they can bend their top jaw up a little bit. And it's all because of the pterygoid bone. So it's jaw flexion that we care about. Switch notes. Okay. All right. Paleognathai is a very highfalutin sounding name, but basically what we're talking about are ratites, which are things like ostriches and rheas and emus and cassowaries, plus kiwis from New Zealand and timamus from South America. These are the only birds today that have that old style jaw. And this is a family tree of these birds. Actually not families, these are orders. But you can see that ostriches are the most different. Rios and emus and cassowaries are more similar to each other, and then Timamus kind of hang out there too. But the ostriches are the most different, separated out evolutionarily earlier than the others did. If you've never thought about it, what makes a bird ostrich-like or a ratite? Well, these are birds that are designed to be on land. They have undeveloped breast muscles. They have no keel on their sternum to attach big breast muscles. They have very small wishbones, which means they don't have a lot of structural strength in their shoulders. They don't have a lot of muscles in their wings. Their legs are very heavy and solid, which makes them heavier. Their wing feathers aren't very impressive. So these are birds that are well designed to not fly. These are running birds. I do want to point out that flightlessness is a secondary characteristic in ratites. They were originally all flying birds, but over time they evolved to stop being flying birds. So most people are familiar with ostrich-like birds. You're probably less familiar with Timamus. This is an elegant crested Timamu. It's one of 47 species of Timamu. Timamu are really pretty common in South America. We just don't know about them here because they don't live up here. Timamus are more similar to the ancestral Paleognaths than the ratites are, both in terms of size and in terms of the fact that they can fly. Okay, that they can fly. Not all of them have crests. This one happens to have a crest. So the question we've been circling, how old are the Paleognaths? Well, the earliest fossil that we have, if you're a rock person, is about 60 million years old. Okay. Until last week, though, essentially every paleontologist I've ever read, believes that they're older than that. The logic being that these old jaws are more similar to the jaws of dinosaurs, classic dinosaurs, non-avian dinosaurs, and early birds, archaic birds, than the jaws of the it's a hard word to say, the new-jawed birds. And so they must be older, okay? And there have been a number of molecular clock theories that ask this question, and generally they say that Paleognaths existed since about 110 to 120 million years ago. And literally before last Tuesday, I would have told you that virtually all paleontologists agree with what's written on this slide. Okay, so they were there, whether we have found them or not, they were there in the age of dinosaurs. They're older than the Neognaths, and that's what we would have believed. A little bit more, and then I'll give you the monkey wrench. So a little bit more about their origin. First off, they first appeared in the northern hemisphere, though we now associate them with the southern hemisphere. They originally, as I said, were flying birds, and they lost the ability to fly multiple times. It's not that one ancestor lost the ability to fly and then diversified. Separate lines of birds lost the ability to fly. They were roughly 10 pounds. Again, virtually everybody agreed that they were there in the Cretaceous, and in fact, most molecular clocks say that ostriches branched off about 80 million years ago, well before 66 million years ago. Okay, I haven't got my monkey wrench. The most important fossil for Paleognaths is this guy here, Lithornis. Lithornis is from about 60 million years ago, so definitely after the age of dinosaurs. A pretty common bird, seems to be because of the number of fossils that we found. Different than modern ratites in that it has a pointy proby beak that it probably poked into holes to find food. But this is the earliest example of a Paleognath that we have a fossil for, again, about 60 million years old. If you want something that looks a little bit more like a classic ratite, you've got to jump to this guy, Diogenornosfragilis. He's about 55 million years old. South American, looks a lot like a rhea, though his wings are a little bit bigger and a little bit smaller than a modern rhea. But you look at this bird and you can believe that it's a ratite, I think, without too much of a problem. And I just very briefly, because it's fun, wanted to mention two other extinct Paleognaths, just because I like them. I like big birds. So if you've never heard of one, there's a type of bird called an elephant bird, which is a family of birds that lived only in Madagascar. They evolved after the age of dinosaurs about 60 million years ago, and they lived until the 1600s. In fact, Marco Polo wrote about them in the 1300s. So we have, very good description of them. These birds were more than 10 feet tall and weighed 1,600 pounds. Think about how many people you could feed with this bird. 7 different species, flightless, keelless sternum, and basically humans drove them to extinction, hunted them to extinction. To give you a sense of how big elephant birds were, here's a human and an ostrich and an elephant bird. So you can see these are quite impressive birds, though they weren't scary. There are scary big birds. This is not one of them because it was a frugivore. It lived on berries and fruits, so it was big, but not scary. The other giant ratite that I'm rather fond of is this guy here, a moa. 9 species of moa. They all lived in New Zealand. They're not quite as big in some way. They're taller, but not as heavy as they were taller, but not as heavy as elephant birds. So big ones could reach 13 feet tall when they stretched their neck up, but they only weighed about 600 pounds. Completely flightless, didn't even have vestigial wings. The wings are completely gone, clearly terrestrial. They went extinct in the 1400s, about 150 years after the Maori arrived in New Zealand. There were no mammals at the time in New Zealand, and so moas took the place of cattle and deer and bison. And just like people in North America, for example, lived by killing deer and bison and cows, the Maori didn't have mammals, and so they extensively hunted moa for food and to use for clothing. Anyway, here's a picture of a moa. This would be the largest species of moa, and you can see it's twice as tall as a 6-foot person. So these are also quite impressive birds. Now I come to the monkey wrench. Here is the monkey wrench. What I've told you up till now is, like I said, until last week, this was going to be easy. This is what everybody agrees with. There's no controversy here. And then this paper came out. Daniel Field published a paper in Nature with colleagues where he discusses a toothed bird from 67 million years ago. That's before the cataclysm, still in the Cretaceous, still in the age of dinosaurs, that had a Neognathi-like pterygoid bone. Oh, that should say bone, not bond. Sorry, bone. That's why I was talking about the pterygoid bone before. Okay, given that it has a pterygoid bone that's shaped like a Neognathi, what that says is it had jaw flexion. It was a new-jawed bird. There has never been before any reports of a toothed bird, which should be very old, that has this new jaw configuration. Field is claiming that this means that neonates did not evolve from paleognates, but rather vice versa. That the reason we don't have fossils of ratites during the age of dinosaurs is because, in fact, they evolved much later. That's what he says. The paper literally came out next week. This is very awkward and hard to talk about, but all I can tell you is you can note this, but I wouldn't take it as gospel yet. This is a contentious field. People say things all the time that by 5 years people have disregarded. I have no idea how this is going to end up in 5 years. What are people going to believe? Are they going to believe that ratites evolved from Neognath birds, or the old story still going to stand? The fact that he has this fossil is beyond question, but here's what the fossil looks like. It's not one of those beautiful Archaeopteryx-like fossils. This is the fossil. It is a partial, disarticulated skeleton that had, in fact, it wasn't just discovered. He looked at it again. It's been around for 15 years or so. And there was a bone that had been labeled as a shoulder bone that he says, no, isn't a shoulder bone. It's a pterygoid bone. And it's a pterygoid bone that looks like a Neognath bone. Okay, so if you don't want to believe Field, and I mean, what I'm waiting for is to get some rebuttals and get some response from other scientists. There just has been no time yet. there very well might be people saying, hell no, you're wrong. It is a shoulder bone. So, your finding is just spurious. The people who have molecular clock models that say that paleogmathy goes back, to 80 million years, 110 million years, I'm sure going to have something to say. They're not just going to say, oh, I guess we were wrong. And it might be, for example, that he's right. It is a pterygoid bone, but that change in shape of pterygoid bone could have evolved multiple times. I certainly don't know the answer. I'm just saying that the fact that there's this study doesn't make me completely reject yet what has been said for many, 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 many years, because it just hasn't shaken down yet. We'll know better in a year or two. So anyway, that's the paleognaths. Okay. So we've got two infraclasses of birds, the paleognaths and the neognaths. And the neognaths themselves can be divided into two very different types of birds, the Gallowanceries and the Neoaves. And I'm going to start with the Gallowanceries. Okay, Gallowanceri is a superorder, and it's made up of two different types of birds, landfowl and waterfowl. Okay? Landfowl and waterfowl, or if you prefer, ducks and chickens. All right. And if you really just stop to think about it, think about a turkey and a goose. You can see that they're related to each other. They're really similar in lots and lots of ways. I mean, they have a very similar body plan and body shape. They both have huge clutches. I mean, 14, 15 babies is really unusual in the bird class. Many are polygamous, which does occur, but is relatively rare among other birds, and they have precocial young. As a package, they're very similar, and they're really pretty distinct from most other birds. Now, when did they evolve? All this is very new. A lot of this, almost everything I'm talking about now is stuff is less than 10 years old, findings that are less than 10 years old. Okay. Just a few years ago, a fossil was found called Presbyornus. It's colloquially called the wonder chicken, and it is from just before the asteroid strike. It's from 67 million years ago. It was found in Belgium, so it's a northern hemisphere bird. This bird is the size of a seagull, and basically it had features of both a chicken-like bird and a duck-like bird. The front half of its body is a lot like a chicken-like bird, and the back half of its body is a lot more like a duck-like bird. So it's an intermediary form. Here's its skull in between a turkey skull and a mallard skull, so you can see how it's really kind of halfway between the two. And, so the question is, I mean, we certainly know that there were Gallowanceri back then. I mean, there were these birds that are definitely in that superorder. But what we don't know is whether it's a basal stock and it's going to be later that you get chicken-like birds and duck-like birds, or it's an evolutionary holdover and there are already real chicken-like birds and real duck-like birds. We don't know the answer to that. But if you're looking at the level of waterfowl, there is no doubt that they existed during the age of dinosaurs. I want to start by talking a little more about waterfowl. Three families of waterfowl. There's the Anatidae, which are the ones that we're really familiar with because they're here in North America, ducks, geese, and swans. There are also two other families, magpie geese, which are really pretty common birds in Australia, and screamers, which are pretty common birds in South America. They're every bit as much waterfowl as our ducks and geese and swans are. We just don't see them here, so we're not as familiar with them. Okay, so any of these, if we have any of these, before the dinosaurs died out, that would count as waterfowl existing then. Well, one of the most important, well-known fossils for people who study this sort of thing is this fossil here called Vegavus. This is a fossil from the late Cretaceous, from before the meteor strike, during the age of dinosaurs, as this picture illustrates. That was a duck. That's what it was. It was a duck. It's about a foot tall, discovered on Vega Island in Antarctica. And again, there is just no doubt that this duck, you can date these rocks, lived before the dinosaurs disappeared, the classic dinosaurs disappeared. Now, you might think this is a rather funny looking duck. You'd say, well, that's a really kind of long, lanky duck with long legs and a long neck. But I wanted to show you a black-bellied whistling duck, and you can see that there are some ducks that actually have a very, very, very similar shape to it. My own favorite fossil, Begavus is really important, but my own favorite fossil of this type that we're talking about is this guy here, Presbyornus. I happen to really be fond of Presbyornus. The earliest Presbyornus fossils are from 65 million years ago, so just after the cataclysm that killed the classic dinosaurs. They're found in North America, they're found in South America, they're found in Australasia. And there's huge numbers of these fossils, and there's huge numbers of them at any given site. So they clearly lived in large flocks, which is why I think this artist chose to depict them as kind of funky looking Canada geese. There are actually two different species of Presbyornus. That's a genus name. There was one that was about 3 feet tall and another that was about 5 feet tall. The earliest fossil of theirs, as I said, it was from 65 million years ago, right after the asteroid strike. However, let me also say that at 65 million years, they're already incredibly numerous and they're all over the world, as I said. That suggests to at least some researchers that they may have been around in the Cretaceous. So I think it's likely they were around in the Cretaceous because they were so numerous and so widespread at 65 million years, it takes some time for that to happen. But I tend to be a rock person, and we don't have a rock for them before the cataclysm. But anyway, that's the logic that some researchers use. I've mentioned magpie geese because this is another fossil from right at the boundary. And again, remember, as I talked about, if you date a rock to 66 or 65 million years, but the error bar is 1 million years, it's really hard to say. So either from the very, 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 very end of the Cretaceous or right at the beginning of the age of mammals. So this is a magpie goose. Was found in examples have been found of it both in New Jersey and in England. So even though nowadays they're in the southern hemisphere, these fossils are from the northern hemisphere. The reason that it's a magpie goose or magpie duck is that its feet are not webbed. That's characteristic of magpie geese, and its bill is more goose-like than duck-like. Again, this is a waterfowl, an example of a type of waterfowl that is right there at the boundary. Well, I'm glad actually Elaine showed this in one of her slides because again, I like to talk about giant birds, so I'm going to do a little self-indulgent thing here and talk about Dremornus. Dremornus definitely did not live during the age of dinosaurs, much, much, much newer, evolved about 15 million years ago. This is an Australian bird. Again, it's one of the largest birds to ever live. It was 10 feet tall, over 1,000 pounds. So not as big as an elephant bird, but really, really big. But one of the reasons it's interesting is it's probably the first animal driven to extinction by humans. And it is a goose. That's what it is. It is a really, really, really big goose. How do we know that it interacted with ancient Australian people? Because there are cave drawings of it and bones that can be found mixed in with the remains of human villages. So they definitely were preyed upon by humans. I know that's self-indulgent, but I couldn't help it. I like those guys. Okay, so I hope we've established that waterfowl, some of them definitely were alive during the age of dinosaurs, and some types are right at the edge, and they look like they're just after, but really, who knows? Then we get to landfowl. The Galliforms. There are 3 extinct families and 5 living families, which would be megapodes and chakalaka. I just have to think about these: guinea fowl, quail, and then pheasants and their allies, which are things like chickens and turkeys. So what we're talking about, landfowl. These birds too lived at the very end of the age of dinosaurs. Okay. This bird is Austin lentis. It was found in 2004 near Austin, Texas, which is where the name comes from. It's just a little bit younger than Asteriornis, that wonder chicken we talked about. So it doesn't answer the question of when Asteriornis was alive, were there also true chickens, chicken-like birds, or not, because he's just a little bit later, but still before the meteor strike. So again, we've got a good example of a land fowl, type of land fowl that lived with dinosaurs. Okay, well, that brings us to the Neoaves. And most birds alive nowadays, you know, of the 11,000 some odd species of birds, 10,000 of them are Neoaves. So most birds nowadays fit into this class. So they are neognaths, they've got the new jaw, but they're not waterfowl or landfowl. And they're a very, very diverse group. I mean, this isn't all of the orders, but you know, a sampling. We've got storks and pigeons and falcons and loons and pelicans and grebes and parrots and penguins and owls and hawks and passerines. So 32 or 33 orders, depending upon which taxonomy you like, of Neoaves. And let me be very, very clear. There is absolutely no fossil evidence that they're from the Cretaceous. Okay, zero, none. I'll backtrack on that just a little bit. So these birds are definitely newer than the birds we've talked about up till this point. Now, even though there's no good fossil evidence for any of these orders of Neoaves to have been alive during the age of dinosaurs, there are some orders that have what I'll call controversial claims to Cretaceous origins. Another way to think about this part of the talk is, if I had to make a case for which Neoaves, if any of them, lived alongside dinosaurs, which would I pick? Which are the oldest Neoave orders? Okay, again, the real problem we have here is that if we do have fossils, they're right at the margin, and the margin, they're right at the edge of when dinosaurs died out, and the margin of error overlaps the age of dinosaurs and the age of mammals. And so it's very, very hard to say definitively. But if I were going to make a case as to which are the oldest orders of Neoaves, here's the ones I would pick. I think you can make the best case for pigeons and doves, which probably surprised you. That's not the one most people think I would say. The molecular models, the molecular clock models, mostly suggest an age that they evolved well before the dinosaurs died out. Okay, so the molecular models definitely think that these are probably the oldest of the Neoaves. There's not 100% agreement about that. Remember, there are different molecular clock models, but some of them at least put them quite a bit, evolving quite a bit before the end of the age of dinosaurs. So that's one reason I would pick them. It's also true that pigeons and doves are very, very different from other passerines. They're the only one that produces crop milk. You know how most birds feed their young regurgitated food? These birds, the lining of their crop sheds and becomes a milky substance, and that's what they feed. It's called crop milk. That's what they feed their young. They're the only ones that do this. They sip water rather than lap it up. They're the only bird that does that. And their feathers are very, very distinctive. If you were a feather expert and you saw just a small piece of a pigeon feather, you'd know that it was a pigeon feather. I am not a feather expert. I can't do that. Okay. The other piece, it's not good evidence, but it's, you know, it's in keeping with this. It's certainly not proof that they evolved in the Cretaceous as opposed to the Cenozoic with dinosaurs versus after dinosaurs, is that, like I said about Presbyornus, the Canada goose type bird that I talked about, they were so widespread so early and so numerous and widespread so early after the meteor strike that, you know, it just makes you say, well, maybe they were around before it, because they certainly traveled really fast and bred like mad. Of course, it is true that the Eurasian collared dove has been spreading like mad in the United States in the past 50 years. So maybe they did just spread all over the world incredibly quickly. But that's another fact that people use if they want to say, I think pigeons evolved during the age of dinosaurs. Also, lastly, modern, very, very modern pigeon and doves in the same genera, the same genuses as our extant species have been around since 55 million years. So they got modern really, really quick, not just in the same family, but in the same genus. So that's another piece of evidence. So if I were going to pick one, I would pick pigeons and doves. Other Neoaves orders that get mentioned would be parrots. Again, not the one maybe that you would have thought of. So parrots, which include true parrots, cockatoos, and New Zealand parrots. All of these are in this order. Again, there are molecular clock models that place them later in the Cretaceous than pigeons, but certainly in the Cretaceous. There are some other models, molecular clock models, that put them in the early Cenozoic. So they contradict each other. I can't distinguish between them, but at least there's some serious researchers who believe that they were alive in the Cretaceous. The case for them living with dinosaurs has actually gotten a little bit weaker in the past few years, because there was a fossil that was dated about 70 million years ago, so again, before 66 million years ago, that had been thought to be a parrot, but that's been discredited. Okay, so the fossil basis of this has gone away. The earliest unequivocal parrot fossil we have is from about 50 million years ago. And like a lot of birds that nowadays we find in the Southern Hemisphere, and we think of as Southern Hemisphere birds, parrots actually evolved in the Northern Hemisphere. The earliest examples we have are all in the Northern Hemisphere. And last but not least, the other birds that I think you can at least make a somewhat of a case for, people do, some people are making a case for living alongside dinosaurs, would be grebes and loons. These are not the same order of birds, not the same type of birds, but the reason I've got them on the same slide is people who believe that grebes lived with dinosaurs and people who believe that loons lived with dinosaurs are basing it on the same fossil. So different researchers are looking at this one fossil, and some say it's a grebe and some say it's a loon. Some say it's neither. Some people who've examined this fossil say, heck no, it's a duck. And other people who've examined this fossil say, hell, it's a Hesperanists. Remember my toothed penguin loon type birds with legs so far back they couldn't stand up? Some people think it's a Hesperanist. So there's no agreement at all about what this fossil is. But there are at least some people who say it's a grebe and a loon. And it comes from the late Cretaceous. Also, there are molecular clock models that put both grebes and loons, some of them, not all of them, at the end of the Cretaceous. So depending upon whose data you believe, you can at least make somewhat of a case that grebes and loons were alive during the time of dinosaurs. So again, some people think this fossil is a grebe, some people think it's a loon, some people think it's a duck, some people think it's a Hesperanist. There's a problem with each of those explanations. No matter which one you pick, I can pick it apart and tell you why it's likely wrong. So there is no good explanation for this fossil, is really what it boils down to. Here's what that fossil is, by the way. It's called Diogenornos. You know how we talk about partial fossils? It's 70 million years old, so it's at the end of the age of dinosaurs. The only part of it that was there is one leg bone. So people are making inferences about this based on one leg bone, which is, rather a difficult thing to do. Well, last but not least, I had to get to the Passerines. And again, you're birders, so you're different. But if you talk to non-birders and you just ask them, what's a bird like? I mean, they give you a description of a passerine, right? They don't talk about chickens. They talk about finches and chickadees and robins, these little forest birds. So they are the most prototypical bird in most people's minds, and they are the most common order of birds. 60% of the world's birds are passerines. More than half of living birds are passerines. So in that sense, they are kind of the prototypical bird. There's 6,500 species of them. They are all over the world. And these are the birds that replace the enantiornists, the ones with the funky tails. Now, there is this very, 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 very poor fossil record of passerines. Think about it. They're small, they're light, they have very thin bones, and they just don't fossilize well. And so this is a case where you might want to lean on molecular clock data, because we know that there could be fossils had the birds been more robust that just aren't there. Well, again, until just a few years ago, because this is an ever-changing map here, most molecular models placed the earliest passerines at about 50 million years ago. This makes them among the newest order of bird, okay? Forget the specifics. The general take-home is that until very, very, very recently, they were considered the most, or among the most recent birds to evolve, okay? Absolutely no one thinks they lived in the Cretaceous. Nobody. I've never seen that ever suggested. Just a little aside, what makes a bird a passerine? Because they're so different from each other. There's so many different types of passerines. Shouldn't have an eagle here. It's that their toes lock in a curled position when they bend their legs. Passerines are perching birds, and the reason they're perching birds, they're beautifully evolved to perch on a twig, because when they're at rest, their toes curl up and lock. So they're really glued onto that branch, and they can fall asleep and not fall off. And that's what makes them a passerine. Anyway, I told you until just a few years ago, everybody agreed that they were really, 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 really new, newer than almost any other type of bird. However, a new fossil was found, and it's this guy here, Sidiyazi abani. It's the oldest passerine fossil we have. It was discovered in 2017. It was discovered in New Mexico on Navajo tribal land, which is why it has, rather than a Greek-sounding first name, a Navajo-sounding genus name. In Navajo, the name Sidiyazi abani means little morning bird. This is an artist's reconstruction of that bird. The reason he made it look like this is if you really look at the skeleton, it appears that its closest living relative would be a mouse bird. So he drew it looking very much like a mouse bird. The fossil was really pretty complete, except it didn't have a beak. So you can't definitively say what this bird ate, but if it is in fact very similar to a mouse bird, mouse birds are frugivores. So probably was a frugivore. I'll show you a mouse bird just so you can see a photo of, rather than artist's drawing. This is most likely not the color necessarily, but most likely what the bird looked like. Mouse birds today are only found in Africa, though, if you go back far enough, they're found in Europe as well. They're small birds, they're gray, they're about the size of red-breasted nuthatcher. So they have very soft, downy feathers, pretty atypical. They've got crests, they've got pretty stubby bills. And in terms of their behavior, mouse birds tend to scurry along branches. That's what they do. I mean, they can fly, but they spend a lot of their time running up and down branches rather than flying from place to place. The second oldest passerine fossil that I know of is Eofringilla rostrum, and it was found in 2019, so even more recently. The nice thing about this bird is that it does have a beak, and in fact, look, you can see what a beautiful complete skeleton this is. It does have a beak, and it has a very finch-like beak, and so it's presumed to have been a seed eater because of the shape of its beak. It's about 52 million years old. So this is more in keeping of what everybody had agreed, and the molecular clock models say that it's from about 50 million years ago rather than 62 million years ago. Has perching feet, it has a finch-like bill, also about the size of a red-breasted nuthatch. A very, very similar bird was also found somewhere in Europe, I don't remember where, that's 47 million years old. So we've got two specimens that seem to be from about the same time. So again, rocks and clocks. The molecular data suggests that passerines evolved in the southern hemisphere about 50 million years ago. What we've got are the two oldest fossils are from the northern hemisphere, and one of them is older than 50 million years. So I can't make sense out of that. In fact, the oldest fossils for passerines in the southern hemisphere are about 30 million years old. So, you know, the data is contradictory. People yell at each other. They call each other idiots and don't agree. And so I certainly can't tell you what is correct. So let me summarize about what I think you can take out of this pretty clearly. First off, there really have been real birds, not modern birds, but real things that you'd have no trouble calling a bird for about 150 million years. Certainly at least 120 million, but I think 150 million is probably right. I'm not going to talk about the field study because it's just too new to really know what to do with. So I'm going to tell you that the first modern birds were the Paleognaths, and they did live alongside dinosaurs. You know, they evolved perhaps 110 million years ago. That's not based on fossils, but on logic and on molecular clocks. Then there are the Gallowanceries, both water and land fowl, that also were around in the age of dinosaurs. And we have fossils and molecular clock data saying so, both kinds of evidence. There were probably or possibly a few living Neoaves orders that lived in the Cretaceous with dinosaurs. Again, if I had to put money down, I would say it's doves and pigeons, parrots, and then loons or grebes. I mean, it's certainly not some things that used to get named because there were some fossils that people thought, for example, were very early penguins that now no longer are considered so. So those are probably the best candidates. Because many modern orders of Neoaves evolved soon after the dinosaur-killing asteroid strike, according to molecular clock data, it's possible that some evolved earlier than that meteor strike because, again, of measurement error. If something is 62 million years old, it really may be 67 million years old. So, you know, there is that possibility, though the best guess is that they evolved after the asteroid collision when there was this huge empty terrain, empty niches all over the place. And that's where you had, you know, this rapid explosion of the types of new types of birds. Most modern Neoaves orders evolved 55 to 34 million years. I really should just say about 55 to maybe 45 million years ago. That's fossils and the molecular clock. And though Passerines had been thought a relatively new order of birds, new fossil findings have pushed that back. So now they're also considered to be pretty much right after that meteor strike. And so just for those of you who are visual, here's the same thing again. True birds, about 150 million years ago is when they evolved. Then you got the Paleognaths at 110 or so million years ago, and modern ones from about 80 million years ago, especially ostriches, Gallowanceries later, but again from the very late Cretaceous with dinosaurs, and then modern Neoaves mostly shortly after the asteroid strike. And that is it. That is my talk. A lot of information. I hope you learned something. And so I'll stop sharing. Okay, I'm done.
I'm stunned.
I hope I made sense. It is very, very murky and confusing, and there's just contradictory evidence right and left, and it changes every year.
Wow.
So it's actually the hardest of the three talks to have given.
Elaine, are there questions in the chat?
I will tell you that in the stunned audience, there is.
I hope not sleeping audience.
No. Everyone's
Hardly.
everyone's on the edge of their seats. Dick Holcomb asked, he thought of the most prehistoric looking bird he's ever seen. He said, how about a Hoatzin as a candidate for one of the eldest?
No, that's one that sometimes gets named. I've never seen it named being seriously discussed as being in the Cretaceous. There are people who say that's among the earliest modern bird that evolved after the KT boundary, but I've never seen anyone really seriously talk about it being from the Age of Dinosaurs. But it's a good one to pick. It's a good one to ask about.
Well,
Yeah, it's got
some
those
of us who are
claws.
just. Excuse me. some of us who really enjoyed seeing the mouse bird because we might have seen them somewhere. And one of our viewers asked, are mouse birds passerines?
I think so. I'm
my
pretty sure.
Now, Steve, you're going to have to tell me what this stands for. Steve Hampton wants to know, what are your thoughts about bird evolution during the PETM? I don't know what that means.
Tell me, I don't know what it means either.
Steve?
PETM.
The Paleocene Eocene thermal maximum, the
Yeah.
climate warming spike. 55 million years ago.
Yeah, well, what do I want to say about that? There are a number of theorists who say that that's when you had peak diversification of modern birds. I don't know why. That's not something I looked at recently, so I'm reluctant to say much of anything. If you just actually sat down with a list, though, of neo-aves and said, when did you start seeing modern families? When did you get an explosion of genera? It would be about 55 million years ago. So it's probably related, but I can't say more than that. Sorry. It was hard enough keeping all this straight.
Oh my God.
I'll have to look that up.
Amazing. For those of
Really
you
good
who might,
question.
for those of you who might be interested, if you scroll up in the chat, there is the reference to that paper in Nature a week and a half ago that our speakers referred to.
Oh, that was terrible timing.
Well, it shows how nimble you are on your feet also.
Well, and again, I don't mean to dismiss it, but as someone who has read this stuff for 40 years, I can tell you that sometimes a finding makes a big splash and 10 years down the line, it's dismissed. And sometimes something makes a big splash and everything turns on its head. And so to me, it's just an open question what ends up happening. And I think you've got to give the researchers who've been saying something very different a chance to seriously look at the data and respond. And again, I'd be very shocked, given the state of that fossil, that everybody's gonna believe that that's a flexible jawbone that you're looking at.
I can't not be impressed that it's in Nature. I mean, it was peer reviewed and somebody thought the methodology was good enough. At any rate, onward our question. Elizabeth asked,
Mouse birds are Coleoformes.
Oh, they are. Okay, I screwed up.
thank you, James
Good.
Carr.
So
I
then we're
recognize
back
that
to,
note.
I should have looked that up. I thought they were Passerines. Then it is still true that the earliest Passerine that we have is 52 million years old, which would still make them, in the scheme of things, relatively new. Okay, so they retain their place as relatively new birds. I am sorry, I didn't look that up and I thought they were Passerines.
Here's a question. Is it correct to say that pigeons and doves evolved from dodo birds or share a common ancestor, and that the Nicobar pigeon is its closest living relative?
Not me. Sorry.
Jim?
Yes,
I
they're all
don't know
in the,
anything about dodos.
they're all in the pigeon group.
Okay, I don't know anything at all about dodos. Sorry. They're not big enough to interest me. I only like the giant ones, giant birds.
Wow, love to see you next to a moa.
Yeah. I mean, dodos were pretty big, but nothing like moa. Mhm. Which
Well,
I've
well,
actually seen a number of, part of the reason I got interested in them is if you live in New Zealand like I did, they're actually mummified moa. So you can actually not just look at the skeletons, you can actually look at mummified birds, and they're quite big and impressive.
Someone who's a scientific wizard said, can heavy metals, exotic isotopes, or other
Mhm.
signatures be found in fossils from just after the cataclysm?
Again, the technique that's used for aging, for dating fossils, is not to look at the fossils themselves. It's to look at the rock that the fossils are in. There certainly have been, one of the ways that's okay, besides the absolute dating with potassium argon dating, there are two other ways that you can say this rock was put down after the cataclysm as opposed to before it. One is in many parts of the world, and it's worldwide, but it had to be where a forest was. There's literally a layer of ash from where the forest burned down. And so if it's below the layer of ash, it's before the cataclysm. If it's after the layer of ash, it's after the cataclysm. And that's if you're a geologist, this is a very obvious thing, this layer of ash, but not every place was a forest. And so you don't have that layer of ash everywhere. The other thing are these heavy metals. And yes, sometimes you get heavy metals in the rocks around the fossils, and that suggests it's right after the cataclysm. I don't know about looking at the fossils themselves because, like I said, all the dating that I know of, you look at the rock, not at the fossil.
Jason Fedora asks, were there giant carnivorous birds that coexisted with
Oh my God, yes.
with humans?
Yes. I actually talked about this in my second lecture, which is why I didn't talk about them today. I love giant birds. In South America, there were an order of birds called terror birds. And terror birds were really interesting because when the cataclysm occurred, all of the predatory reptiles disappeared. And so did all the predatory mammals. And so there was a period of time in South America, and South America was an island at that point, because remember, with sea level rise and fall and continental drift, the continents weren't in the places they are now. But South America was an island. And so this group of birds called terror birds evolved to be the apex predator in South America. And they lived for millions and millions and millions of years as the apex predator. How do we know they lived with people and preyed on people? Because we have found skeletons of terror birds with human bones and teeth in their stomachs. So now they could have scavenged. Nobody knows if they hunted them or scavenged them. But the fact that they have human bones and teeth in their stomachs strongly suggests that they interacted with and ate people. So there's that. And the reason the terror birds died out is, I like to say, these birds were really, really big and scary. The way they killed their prey, they had really strong, heavy hatchet-like beaks, is they actually hammered the heads and necks of their prey. And they were tough enough that they could, like a pickaxe, go through the skull of their prey. So these were really tough birds. They were tough, but saber-toothed cats and dire wolves were tougher yet. And you can trace in the fossil record as when the earth cooled and sea levels dropped, now you have a land bridge between North America and South America. That's Central America, but it didn't exist back in, if you go back far enough. But now you have this land bridge, and you can trace in the fossils saber-toothed cats and dire wolves moving down from North America. And as they move down, the terror birds disappear. I mean, you can just see this happening as a wave. So yes, there were big carnivorous birds too that interacted with people.
Well, how about a tiny bit of wisdom from our president, which applies to a lot. The more that is known, the less is certain. And the more you're certain, the less you will be, as more is known.
There you go. It certainly fits this talk.
We have a question about, sort of rhetorical, I guess, but who will validate or refute Daniel Field's discovery?
Well, he's at Cambridge. I mean, I said he's a very credible researcher. This is hardly his first piece of research. I mean, he is a very well-respected paleontologist. Who will refute? I am sure other paleontologists, say from the American Museum of Natural History or, from University of Colorado, will go there and ask to see the fossil and look for themselves, or certainly photos or videos of the fossil and the bone, and ask to see for themselves. I'm pretty sure that, well, I shouldn't say that. It's very likely that it was a credible person who first identified it as a shoulder bone. It's very hard when you've got a disarticulated skeleton and sometimes partial bones to know exactly what's going on. Certainly the molecular clock people are not going to take this sitting down. I don't know what they're going to say. I don't know how they're going to rebut it, but I cannot believe, I mean, there's so many people working on molecular clocks that they are all going to quietly just go, oh, whoops. And I don't know what they're going to say, but they'll certainly have a say, even if they end up agreeing with him. They're going to insist on, you know, having a look and trying to reconcile things. And again, to me, at the very least, because people always like to make a splash and make a finding as important as it can be. And it's an important finding no matter what. But let's assume that you do have a toothed bird that has a flexible upper jaw. It still doesn't, to me, necessarily prove, using logic, that neognaths are before paleognaths. Because you can have something happen multiple times. I mean, sometimes the same feature evolves in creatures in different lines. For example, snakes, who are not at all closely related to birds, also can flip up their upper jaw. I mean, this has evolved more than once. Another example of that would be opossums, pouched mammals, can have prehensile tails. They can hang by their tails. They can wrap their tails around tree branches and hang from them. So can New World monkeys. They're not closely related, but they both end up with the same trait. And I'm absolutely making this up when I say it, but one out for people would be to say that. To say, okay, yeah, you're right, but it still doesn't necessarily follow that paleognaths are newer, because it could have been convergent evolution. I mean, but I don't know what they're going to say, but that's what I would be thinking if I were one of these guys.
I want to turn to Martha Jordan for a moment to, if folks want to look in the chat, she had given us some information early on about avian influenza to turn to our current birds, and also had a fine comment that this was fascinating information and your perspective and perceptions were so appreciated. Another viewer said, I finally get it.
Well, you know, what's nice is I don't have a dog in this fight. I mean, I'm not a researcher, you know, I just read research. And so, you know, it's no skin off my nose whether the fossil guys are right or the molecular clock guys are right. You know, I mean, I just try to read everything I can and try to see who makes the best persuasive case.
Well, even knowing what the fights are about is interesting for many of us who are, I mean, I find this fascinating. I mean, I didn't even know what the arguments were, and still don't, but no more than I did before. I just found this an amazing talk. I'm really grateful to you.
Oh, well, like I said, thank you. I've really been very nervous about it because it is so murky. I mean, just, you know, it's easier to tell a story when everybody's on the same page. But anyway, that's all I have. It says, ask her about Clara. Clara's my beautiful 11-month-old granddaughter.
Excellent. Well, if anyone else is inspired to ask him a question, please either type it in or just unmute.
Well, I think this is a stunning way to end the year.
Well, I'm glad you think you learned something. Like I said, this is going to change in 10 years. It'll be different, but that is the best snapshot I can give you of what people believe right now.